Hey guys, welcome. I have a special guest here today. This is Cameron, and he is obviously in homeschool right now, so he is helping me out. And we're talking about atoms today, right? We're talking about atoms and the different type of chemical bonds that form between molecules. So on the first day of class, we said that the tiniest little pieces of a human body are what? Atoms, that's right, that's right. Tiniest pieces of the human body are atoms. Everything in our world, if you zoom in to a really small scale, are made up of these tiny little things called atoms, right? Now, what we're gonna do is I'm gonna kind of show you what one of these atoms looks like. An atom comes in three different parts. The nucleus is the center of the part, and it contains two things that make up an atom. Two things are located in the nucleus, and those things are called protons and neutrons. I'm gonna draw protons in blue, all right? So imagine, let me kind of back up. I'm gonna draw an atom of oxygen, a very common atom in our world, right? And there's a lot of oxygen in our bodies because we're mostly water. Well, water is one oxygen and two hydrogens, okay? So let's see here. I'm gonna draw a picture of oxygen right here. All right, so this is oxygen, okay? Now oxygen is gonna contain 8 protons, and it's going to contain 8 neutrons. Okay? These protons and neutrons, they hang out in the middle of the atom and they make up the nucleus. So these 8 protons, I'm gonna draw these guys in blue, okay? We're gonna have 1, 2, 3, 4, 5, 6, 7, 8, okay? Those are the protons. Do you know what charge protons have? What charge do they have? Electrical charge. Positive, negative, or neutral? With a name like proton, they might have a positive charge. You got it. So these protons are positive. Great. Now, neutrons, I'm going to draw these guys in orange. Okay. These neutrons are going to be like this. Oxygen also has 8 neutrons. 1, 2, 3, 4, 5, 6, 7, 8. Okay? What charge do neutrons have?
Negative.
Close. Neutral. Right? So they don't have a charge at all. So I'm just going to draw an X with a circle around it because they have no charge. Now, one important thing about this nucleus that's made up by these protons and neutrons, that's the heavy part of the atom. 99.9% of the weight or the atomic mass from this molecule comes from that nucleus, right? Do you know that? Yeah, you do know. Okay, well, there's one other part of the atom, and these guys, anybody know, or do you know what they're called? What's the last part of the atom? Electrons. Yeah, so electrons, anybody, you know what charge they have? Positive, negative, or neutral?
Negative.
Negative charge. Good. These guys have a negative charge. They are very light. They don't weigh a lot, and they are gonna be hanging out on the outside of the atom. They actually fly around the nucleus in these very specific patterns. They're called orbits. Okay. The first pattern or orbit that is going to contain electrons is located pretty close to the nucleus. He's located right there. These electrons, I'm going to draw these guys in red, right? So electrons are going to be in red. This first little orbit can contain 2 electrons, and it wants to contain 2 electrons, but it can't hold any more, okay? Once that first little pattern or orbit, or shell is another word for it, once it contains 2, he's full and he's happy. Can't contain more than 2, okay? But we've got how many more?
Space.
Yeah, well that's the crazy thing about an atom. There's a lot of empty space. In fact, most of it empty space. It's most of it just occupied by these tiny little electrons flying around the atom. This table is made up of a bunch of atoms, which are mostly empty space. Any ideas on why we can't like push through it?
Because it's hard.
Yeah, it's hard. But that's actually a topic for another class. It's like quantum mechanics. It's tricky, but most of the atom is empty space. Now, where are the other 6 electrons going to go? Can we put them in this first shell? Nope. Won't fit, right? We need another shell. That other shell is going to be located out here. It's a pretty bad circle. That's okay. How many are going to be located in the second shell?
6.
Yep. 1, 2, 3, 4, 5, 6. Now this second shell can hold 8. It wants to hold 8. If it doesn't hold 8, he's not happy. Is this atom happy?
No.
No, because he only has 6 in that outer shell. He wants 2 more. In fact, so this oxygen atom is going to achieve that stable kind of arrangement with 8 electrons in its outer shell through chemical bonds, right? Right. By himself, he's not happy.
Yeah.
Okay. So that's kind of the stage, the what an atom looks like. Now, a couple other things about an atom is that the number of protons determines the atom that we're talking about. If you come across an atom that has 8 protons, he has to be oxygen. Right?
Yep.
That's just how it is. Another atom is hydrogen. Hydrogen has 1 proton. Hydrogen actually looks pretty pathetic. So if I were to draw hydrogen has 1 proton, he has 0 neutrons, and he has 1 electron. Okay?
That's pretty pathetic.
That is pathetic, huh? So his nucleus is gonna have, well, not blue. This is what hydrogen's gonna look like. He's gonna have 1 proton in the middle.
Mm-hmm.
And then how many electrons is he gonna have?
1.
He's gonna have 1. Is he happy?
No.
By himself. Is he happy by himself?
No.
No, what does he want?
He wants more.
How many
Wait.
more?
1 more.
That's right, and that's exactly what he's looking for to achieve a stable arrangement. Now, point is, if you come across an atom that has 1 proton, he has to be hydrogen, right?
Yeah.
Cool. All right, now, we are going to talk about a couple of different types of chemical bonds, okay? One more other thing before we kind of go on. An oxygen atom can have a different number of neutrons. That's just called an oxygen isotope, an isotope of oxygen. That's the last time we'll talk about isotopes. You can also come across an oxygen atom that has a different number of electrons. You might have 7 or 9 or whatever electrons. That's called an ion of oxygen. But if he has 8 protons, he's got to be a oxygen molecule, okay? What the heck is Tyler doing? He just left the house?
He's left.
That's ridiculous, man. So that's the general structure of an atom. Now we're going to talk about how atoms like oxygen, who aren't happy by himself, can achieve like a stable arrangement through chemical bonds. The first type of chemical bond that we're going to talk about is called a ionic bond. Okay, here's the definition of an ionic bond. It's when one atom gives another atom an electron, and they go their separate ways.
So
Okay.
it just gives it to him?
Just gives it to him, okay? It's kind of like this. Imagine you are going to class with your best buddy, right? And on the way to class or on the way to school, he calls you up and he's like, hey, I'm super thirsty this morning. Can you bring me like a soda, right? And you're like, I have soda in my refrigerator. I'm gonna bring you a soda, okay? You bring him like a Sprite or something, right? You see him at school, you give him that Sprite.
Then
Now, are you gonna share that Sprite? You're gonna like pass it back and forth and take a sip, he takes a sip? No, right? You're just gonna give it to him. It's yeah. He's gonna go to class, you're gonna go to class, right?
no.
Because you gave him that soda, do you think your friendship's a little stronger? Yeah, right? Well, that's exactly how it works with an ionic bond. One atom gives an electron to another atom, and there's a weak attraction between the two of them. A great example is table salt, which is sodium chloride, okay? It's like the salt that we eat.
Mm-hmm.
Sodium has this type of situation. He has got 11 protons, 12 neutrons,
It's a lot.
and 11 electrons. So let's draw him out really quick, okay? So how many blue dots is he gonna have in the middle?
He's gonna have 11.
11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, good. How many orange dots is he gonna have in the middle?
12.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay? Good. Now, how many electrons are gonna be in that first shell?
11. Wait, no.
How many are gonna be in that first shell? This
So-
one right here.
Wait, so we already...
Well, we're at electrons now. How many can be held in that first little shell?
2. Only
2. How about more? Any more?
No.
Nope. Good. Now, how many are gonna be held in that second shell that I just drew?
11.
This
No.
second shell, how many does he want to hold?
He wants to hold 8.
He wants to hold 8. Can he hold more than 8?
No.
Nope. That's all he can hold. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Are we good? Are there any left over? What's 2 plus 8?
It's 10.
10. How many electrons are there?
11.
11.
There's one.
One left over. Can we just cram him into that shell
Nope.
right there?
You give him.
Nope, we can't. He has to be by himself. Oh no, that's smear. He has to be by himself in this shell out here all by himself.
That sucks.
Yeah, do you think that this atom is happy? Does he want to get rid of that guy?
Yeah.
Yes, okay, that's a problem for him. Chlorine's got a very different situation. He's got a very different problem. Chlorine has 17 protons, 18 neutrons, and 17 electrons. How many blue dots in the middle?
17.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11,
Okay,
17.
you need to redo that.
No, it's fine. How many neutrons in the middle?
18.
Good enough. All right. How many electrons are going to be
17.
in that first shell?
I mean, nope. Well, 17 is only going to be 2.
That's right. He's going to have 2. How many are going to be in the second shell?
8.
How many are going to be in the last shell?
Okay, so 8.
We got 8
9.
plus 2. Oh, but how many electrons are there total?
17.
So 17 minus 10?
7.
7. 1,
What did I get?
2, 3, 4, 5, 6. Don't worry, your summer school teacher isn't very good.
No.
Your homeschool teacher isn't very good. 2, 3, 4, 5, 6, 7. So he's got a problem. What does he need? Is he in a stable arrangement? He's got 7 in that outer shell. What does he need?
He's pretty stable.
Well, no, that outer shell wants 8. He's got 7. He wants 1 more, right?
Yeah.
Well, he looks at sodium and is like, dude, you have 1 extra electron. Why don't you just give that to me? And sodium goes, that's a perfect idea. I don't need this. This is like the extra soda. This is like the extra Sprite. So this electron is going to come right over here. Boom. Right there. This guy is no longer located right there. We'll put an X through him.
Well, like, what if...
Now, listen. What's your question? Sorry.
So, if he has an extra one, couldn't he use that for some pros or cons? Like couldn't he use that?
No, it's not like that. It's not like having an extra one is a good thing. He wanted to get rid of it because, like, he just wants a stable arrangement of having 8 in the outer shell, and he had 1 more, right? I mean, you had like an extra Sprite that you just couldn't even like hold on to. You didn't even have a pocket or a book bag for it. You had to give it to your best friend.
Yeah.
You just wanted it so that way you're like comfortable, you know? Okay, but now check this out. Why does this atom now have a positive charge? And why does he have a negative charge?
Because that one's negative.
And he lost
Yeah.
a negative thing. So now he has 1 less electrons. Now he only has 10 electrons and he has 11 protons. He has 1 more positive thing than negative thing. He has a positive charge. Why does this guy have a negative charge?
Because he gave it.
Yeah, that's right. So now he has 18 electrons. Okay?
More
This is called an ion because he has a different number of electrons than the normal atom. What do we know about positive and negative things? Think about a magnet. The positive side of a magnet does what to the negative side?
goes away, or no, sticks.
They stick. Opposites always attract.
Yeah.
So there's going to be a weak attractive force between these 2 ions. They're like a magnet. That is an ionic bond.
Do they come together?
Yes.
Or
They
what
stick
happens?
together and they
What
form a
happens?
crystal. And they actually form, so I'm going to change up the color scheme a little
That's
bit.
why there's huge crystals in there?
That's right. That's why rocks, salts, they're all crystals, right? And so if you were to zoom in on table salt, it would look like this. So imagine these blue dots are sodium. You'd have all of this, different layers of sodium. And between them, that's where you would have the chlorine in yellow. You'd have and they would just stick together like this in this big 3-dimensional crystal that looks like that.
So those big crystals, how much would that have to take? Those huge crystals.
Oh, how many atoms are in
Yeah.
there? How many do you think? 1,000, 100,
Trillions.
million, trillion.
Trillions.
There's because this is so small.
Yeah.
This is so small. Our microscopes can't even see it. Like literally, this is so small. You'd have to have a super special microscope. So that's what table salt looks like, and then the blues are sodium and the yellows are chlorine. Okay, so that's an ionic bond. Okay, The next type of bond that I wanted to talk about, that is called we're running out of room here, but that's okay. That is called a covalent bond. We're gonna do a covalent bond right here. Covalent bonds are different. I'm gonna give you the definition. Covalent bonds occur when two atoms share electrons. Okay? They share them.
So
This is gonna be tricky. It's like you and Tyler, your brother. You're gonna share your Xbox.
that's not gonna happen. It's not happening.
Okay. But let's imagine we have two hydrogens. Okay. Let's say we have two hydrogen atoms. There's one hydrogen atom. Let's draw another one. Hydrogen atom consists of that one proton in the middle, right? And you're gonna have an electron floating around them. Okay. I have an idea. I think an ionic bond is going to work really well for these two. Because how many more electrons does this guy need
He needs. Wait.
to be happy?
One more.
One more, because two will fit in that outer shell. I got an idea. How about what if this guy just gave an electron to that guy so this hydrogen atom could be happy, and that hydrogen atom, he'll just figure something out? Do you think that would happen? No way, right? Atoms don't work like that. Okay,
Like,
so an ionic bond is not going to work. But what if these two guys shared these two electrons? So let's imagine
give it to him
they
for
like
a short period of time, then.
kind of, but let's say they're stuck together so that the two electrons go around both of them at the same time.
Ooh,
So let's
that
say
sounds fun.
they get super close together like this. The shells of their electrons are going to overlap like that because they're super close together. And now the two electrons are gonna circle around both of them. Everybody's happy. That's called a covalent bond. Couple things about a covalent bond. They're a lot stronger than ionic bonds, right? Super strong. They contain a lot of energy too, right?
Okay.
It takes energy to form them, and when they break, a lot of energy is released.
Can this create a crystal? Just this?
No. Crystals are made up of ionic bonds. These make up different things, like wood, our bodies, right? We're made of covalent bonds. Now check this out.
Wait, so it's in our body right now?
Oh, we're made of nothing but covalent bonds. A bunch of atoms stuck
So
together
your
through
bones are made
covalent
of
bonds. Oh, tons, millions, trillions.
Oh.
So check this out.
That's why we're doing this. I thought we were just talking about the ground.
Yeah, right. So, but check this out. This is what's important. Covalent bonds contain a lot of energy. It takes a lot of energy to form them. Imagine you have these two hydrogen atoms. In order to form a covalent bond, you have to squeeze them together. Imagine there's a spring between them, so you have to like squeeze them together.
Couldn't
And when
it
they're
be like
close
a magnet?
enough,
Like a magnet?
well, they don't really want to get close.
Yeah.
But then you lock them together with like a lock. That's the covalent bond. What would happen if you break the lock? They would explode, and that's
Just
exactly
like a
what
magnet?
happens.
'Cause
Just
once
like a
you
magnet.
lock
But
them-
when they explode, they release energy. And that energy is released in the form of heat, radiation, and light.
that's how they make lights.
That's why things burn, right? Anything that burns is
So
made
it's
up
like
of
locked,
covalent bonds.
split, like locked inside the wood, and then.
When you put wood on a fire, those covalent bonds get heated up and they break. And when they break, they release light, heat, and radiation. That's what fire is. That fire causes more covalent bonds to break, and so forth. Let's say you're building a fire in the backyard with your buddies, and you tell your buddy Abram to bring something to put on the fire, and he shows up with a rock. Would that make the fire burn? No. So what type of bond is that rock made up of? Ionic or covalent?
Ionic.
Yeah, no energy, right? Now, all the food that we eat, all the sugars, all the fats, do you think they're made up of ionic or covalent bond, which contains energy?
Covalent.
And we break those bonds
To
so
make
we can do
have
everything that
energy.
we need to do.
Yeah.
So we can grow bigger, all that. Now, there's two types of covalent bonds that we need to talk about. There's polar covalent and there's non-polar covalent. Okay? A non-polar covalent is an example like this. That occurs when these two atoms, they share equally. They share the electrons equally. Like this hydrogen's about the same strength as that hydrogen, right? They're gonna share these electrons equally. Nobody's stronger than the other one. Water is not. Water is an example of a polar covalent. Okay, right here. So polar, let me scoot it down. A polar covalent bond looks like this. You're gonna have a water molecule, so you're gonna have oxygen. I'm gonna kind of simplify things. So we're gonna have all these protons in the middle, right? All these electrons in there too, right? And then how many electrons are gonna be in that first shell?
2.
And then how many are gonna be in the second?
8.
Nope.
I mean 6.
Good. So you're gonna have 1, 2, 1, 2, 3, 4, 5, 6. Okay. How many more electrons does water want to have?
7.
He's got 6. How many needs to be in the outer shell to be happy?
8.
Yeah, so he needs 2 more. Well, water is H2O, 1 oxygen, 2 hydrogens. There's gonna be a hydrogen right here and a hydrogen right there. I'm kind of running out of room, but that's okay. So it's gonna kind of look like this and like this. Okay. Boom, boom. So these are 2 covalent bonds. The 1 electron from hydrogen is sharing with oxygen, and he's doing the same thing. So if you add them all up, you get 1, 2, 3, 4, 5, 6, 7, 8. Is oxygen happy with 8? Yes.
Yeah.
Is hydrogen happy because he's got 1, 2, 1, 2?
Yeah.
Yeah, he's happy. Everybody's happy. But here's the deal. Oxygen. Who's bigger, oxygen or hydrogen?
Oxygen.
He's bigger and he's stronger. So he's going to cause the electrons to hang out on his side more often. He's going to hog those electrons. It's kind of like when you and Tyler play on the Xbox together. You're kind of bigger and stronger, and you kind of like take longer turns.
Well, because
Whatever. Right, so you're bigger and stronger, so you're going to hog the time on the Xbox. He's going to hog the time with these electrons. And these guys don't get to hang out with the electrons as much. They're kind of pulled over to that side. So if the electrons are spending more time over here, what happens to the charge on this side of the water molecule? Electrons, what charge do they have?
Not much.
The charge, electrons have a negative charge, right? So if electrons are hanging out over here more, what happens to the charge on this side of the...
Probably
gets negative. Gets more negative, okay? And then on this side, it gets more positive because the electrons aren't spending time over there.
Yeah.
If something has a positive and negative side, it's a magnet. Water is a magnet.
It is?
Yep, it's a tiny magnet. If you have a bunch of magnets and you put them in the same bag, do they stick together? Heck yeah, that's what water does. You pour water on the table, you know how it beads up into a bead? That's why, because water's magnets. That's how it works. Now check this out.
So if you like stack, like you put a bunch of water in a glass and you like kind of like...
Remember it forms the meniscus up top?
Yeah.
That's because the water's sticking together. Now, check this out. So, different water molecules are going to be attracted to each other. How can I draw water? We'll draw water as like light blue and green, right? So we'll say that like this is a water molecule, the oxygen is blue, and the hydrogen is green, like that, boom, boom. That water molecule is going to be attracted to his neighbor, the next water molecule, right? They stick together. The hydrogen side has what charge, positive or negative?
Positive.
He's going to be attracted to which side of the next water molecule? The negative side, right? Because opposites attract. So all these water molecules are going to stick together like that. That weak attraction between different water molecules, that's called a hydrogen bond. And that's the last type of chemical bond that we'll talk about. Okay? What happens when you put salt in water?
What's it called? Like, goes away. Well,
Dissolves.
Yeah.
Right? It dissolves. Why? Is that magic?
No.
I mean, think about it. It just disappears.
I mean,
Where does it go?
in the air.
No.
Wait,
No.
I mean, the water does that.
It's in the water.
It goes in it.
Why can't you see it anymore, though?
Because it's microscopic. I mean,
Nah, you're actually not wrong. Here's what happens. Here's our salt crystal, right?
Small.
This is sodium, and this is chlorine. Let's put that salt crystal in water. What charge does sodium have?
positive.
Positive. What charge does chlorine have?
Negative.
Negative, okay? Is water going to be attracted to these positive and negative things? Are magnets attracted to positive and negative things? Exactly. So what'll happen is that which side of the water molecule is going to be attracted to the positive sodium? The oxygen side or the hydrogen side?
Hydrogen.
No. No, sodium is positive, so the oxygen side is going to be attracted to him. So we're going to get all these water molecules attracted to him with the oxygen side on that side and the sodium kind of pointing on the other direction like that. And then for the yellow chlorine, the hydrogen is going to be attracted to him because that chlorine is negative and the hydrogen is positive. So you're going to get this type situation, and what will eventually happen is that these water molecules are going to pull these sodium and chlorine ions out of the crystal, and they're going to surround them like this. So you're going to have chlorine over here, and he's going to be surrounded like this by all these different water molecules that look like that. Now, if this little chlorine ion is completely surrounded like this, are you going to be able to see him? Can you see a single atom? Are your eyes strong enough to do that? That's why it disappears, because it gets completely surrounded by water. Same thing happens over here. Let's take the positive blue sodium right here. He's going to be completely surrounded by water, but the other end of water is going to surround him like that. And we'll draw the hydrogen over here. Boom, 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 boom. Then, when the water evaporates, the sodium and chlorine are left behind, and the salt forms at the bottom of the glass after it evaporates.
Okay.
So, in review, what type of bond occurs when one atom gives an electron to another atom?
Iconic bond.
Ionic. Good. What type of bond occurs when two atoms share electrons? Covalent.
Yeah, covalent.
Which type of bond occurs when different water molecules are attracted to each other?
It's
Hydrogen.
yeah.
All right. Two types of covalent bonds. You got non-polar covalent and polar covalent. Which one occurs when the electrons are shared equally? Like in hydrogen.
The
Non-polar. Right. All polar means there's a positive and negative side. Non-polar, there's no positive and negative side.
Yep.
Which one occurs in water where the oxygen hogs those electrons? Polar. That's it, man. Which type of bond contains the most energy? Covalent, ionic, or hydrogen? Covalent. Perfect. Good job. And that, my friends, is it.